Hello, I am Tajkia Jahan Rakhi and I am back with another ArcGIS video. The application of geoprocessing tools will be our topic today. So what are geoprocessing tools? Geoprocessing is built on a data transformation framework. A typical geoprocessing tool operates on an ArcGIS dataset, such as a feature class, raster, or table, and produces a new dataset. Each geoprocessing tool performs a little but necessary action on geographic data. These are the topics that we will cover today. So our first topic will be Search Toolbox and Arc Toolbox. To begin, launch ArcMap on ArcGIS and look for geoprocessing in the upper toolbar. Click Geoprocessing, then go to Arc Toolbox. Then from Arc Toolbox, go to Analysis Tools, where we can find Extract, Overlay, Proximity, and Statistics. And we can see geoprocessing tools to use in these. These tools can be used to create a variety of files. We can also use the search toolbox to find any tool in the Arc toolbox, making it a speedy procedure when working with geoprocessing tools. Our second topic will be buffer tool. Buffers are proximity functions. When you use this geoprocessing tool, it creates a polygon at a set distance surrounding the features. For example, a buffer is a polygon or collection of cells that are within a specified proximity of a set of features. The buffer tool can have fixed and variable distances. Also, they can be set to geodesic, which accounts for the curvature of the earth. So on the buffer tool, click the input features drop down arrow, then select the file you want to buffer. Here I am selecting important feature for my input features. Change the default output feature class name and select where you want to save the shape file. I want to save it in this folder. And you have to rename the file. Click the adjacent drop-down list of distance units. Here you can select parameters in which you want your buffer distance value to be. I will select meters. In the distance value field or box, define the distance. Here I will select 30. The other things will remain the same and click OK. Here is it. My important location is buffered. These were points and these are buffered into polygons. Our next topic will be clipping tool. The clip tool is an overlay function that carves out an important layer with the extent of a defined feature boundary. The result of this tool is a new clipped output layer. If you can picture a cookie cutter, this is like using the clip tool. And carving out vectors and rasters is one of the most common operations in GIS. To clip data, you need points, lines, or polygons as input and a polygon as the clipping extent. The preserved data is the result of a clip. On the clip tool, click the input features drop down arrow, then select the file you want to clip. Here I am selecting rows for my input features. Then click the Clip Features drop-down arrow, then select the file you want to clip with. When the inputs are polygons, the clip features must also be polygons. When the input features are lines, the clip features can be lines or polygons. When the input features are points, the clip features can be points, line, or polygons. Here I am selecting weight boundary as clip feature. So all the rows inside weight boundary will be cropped. The output feature class will contain all the attributes of input features. Here, change the default output feature class name and select where you want to save the shapefile and rename the file. Then click OK. Here is it. You can also change the color to see it clearly. Here is it. Our fourth topic is the Intersect tool. The Intersect tool is very similar to the Clip tool because the extent of input features define the output. The only exception is that it preserves attributes from all the datasets that overlap each other in the output. The Intersect tool performs a geometric overlap. All the features that overlap in all layers will be part of the output feature class. Attributes will be preserved. Try to add multiple inputs. The tool accepts different data types, point, line, and polygons. When features overlap each other, they will be in the output. The Intersect tool preserves the attribute values in both input layers. Here's a pro tip. Run the Intersect tool on a single feature you can find overlaps. On the Intersect tool, click the Input Features drop-down arrow, then select the file you want to do your work with. Here I am selecting buffer for my input features because buffers intersect with each other and have a common area. You can also select two features that intersect with each other. Change the default output feature class name and select where you want to save the shapefile and rename the file. Then click OK. So I am renaming the file. The Intersect tool will be applied successfully. See the intersected area. Our next topic is union. The union tool creates a lot of features. The union tool maintains all the input features, boundaries, and attributes in the output feature class. The input features are geometrically intersected. The output feature class will contain features or sections of features that overlap in all levels or feature classes. The union tool spatially combines two data layers. It preserves features from both layers to the same extent. In union, all input feature classes and feature layers must have polygon geometry. So click Input Features and select the data layers you want to combine. Here I will select water body and playfield as input features. Change the default output feature class name and save it. So all the play fields and water bodies are combined together here. Our next topic is merge. The merge tool combines data sets that are the same data type, point, line, or polygons. When you run the merge tool, the resulting data will be merged into one. Similar to the clip tool, we use the merge tool regularly. For merging data sets have to be the same type. For example, you cannot merge points and polygons into one dataset. Although union and merge sounds kind of same, but there are some differences. In union, boundaries of each features intersecting together shows in output. But in merge, while intersecting, only one boundary at a time shows in output. On the merge tool, click input datasets drop down arrow, then select the file you want to merge here. Here I am selecting my previously buffered important features for my input features. Changing the default output feature class name and save. Then click OK. See, all the buffers are merged together. Now we will learn the dissolve tool. The dissolve tool unifies boundaries based on common attribute values. In other words, dissolve merges neighboring boundaries if the neighbors have the same attributes. For example, if you want to remove the borders of geographic units, you can use dissolve tool. Dissolving lines input create multiple features. This means that one record can have several polylines. If you dissolve a set of points, then you can have multi-point features as well. Click input features, then select the data layers you want to combine. I will select buffer as input features. Changing the default output feature class name. In dissolve fields, you can select fields that you want to dissolve together. Then click OK. See, the intersected parts are dissolved together now. Our last topic today will be the identity tool. The identity tool computes a geometric intersection of the input features and identity features. The input features or portions thereof that overlap identity features will get the attributes of those identity features. Input features can be point, multi-point, line, or polygon. The inputs cannot be annotation features, dimension features, or network features. The identity features must be polygons or have the same geometric type as the input features. When using this tool with point input and polygon identity features, points that fall directly on polygon boundary will be added to the output twice. Once for each polygon that is part of the boundary. Running the intersect tool on the output of this scenario will identify the duplicate points so you can decide which one to keep. In short, it can be said that identity tool is mainly total of intersect, union and merge tool. First, this tool performs intersection, then union and lastly, all the things are merged together. First, open the identity tool. On the identity tool, click input features drop down arrow, then select the file you want to merge. Here I am selecting my previously buffered important features for my input features. Then select identity features drop down list. and I will select quit boundary as my input features. Then select OK. You can see all the features are put together here. So that's all for today. See you in the next video of ArcGIS. Until then, goodbye.